In this video, I'm going to show you some basic things for starting to deal with sine, cosine, and tangent. In the first example, I have a right triangle, and it says to name the side opposite angle A. Here's angle A, so opposite that angle would be all the way on the other side of the triangle. That would be this side. Now, to name a side of a triangle, you need two letters, so I would choose the two endpoints. So I could either name this side CB or BC. Either one is referring to the same side. To name the side that is adjacent to angle A, I need to make sure that I'm picking a side that is a side of the right angle. Okay, so either this one or this one. These two sides form the right angle. And adjacent means next to or touching. So if I'm choosing one of these sides that needs to be next to or touching angle A, it's going to be this side. And again, I need two letters, so I can either name this side AC or CA. Once you can tell the difference between opposite and adjacent, you can use those to fill in your sine, cosine, and tangent for your different angles. If you remember SOHCAHTOA, you can remember the fractions for each of those. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So each of those letters either stands for a trig symbol or what sign of the triangle you're dealing with. So for the sine, cosine, and tangent of angle G, okay, I'm using G to get the sine, cosine, and tangent. So sine would be opposite over hypotenuse. I'm choosing the side that is opposite angle G, so that would be 5. That's on the opposite side of the triangle. Over hypotenuse, remember the hypotenuse is the side across from the right angle, so that's 13. Okay, and then that's how I would leave this, unless it says to express it as a decimal. Usually a fraction is fine. The next one is cosine of G. Cosine is adjacent over hypotenuse. So here's my angle, G. I need the side that is adjacent, so that would be 12, over the hypotenuse, which we know is 13. And the last one for G would be the tangent. So tangent of G is opposite of G over adjacent. So we know opposite is 5. Here's angle G, this is opposite. And here's angle G, this is adjacent. So 5 over 12 would be tangent. Okay, now I'm gonna go through and do sine, cosine, and tangent again, but I'm using angle F this time. So what's opposite of angle F will be different from what was opposite of angle G. Opposite of angle F would be 12, and the hypotenuse is still 13. Okay, so sine would be 12 over 13 for angle F. Okay, cosine, adjacent over hypotenuse. F is here. This is the side that is adjacent. It's right next to it. And this is the hypotenuse. 13. Tangent of F would be opposite over adjacent. So here's opposite, adjacent, 12 over 5. Okay, now there are a couple things that you can notice about the two acute angles of a right triangle. Whatever my sine was of one acute angle, that was the cosine of the other. Same thing with the cosine of this one. That was the sine of this one. Okay, and for tangent, tangent of one is the reciprocal of tangent of the other. That will always be the case. Okay, because you only have 3 sides, so they get reused. If it was opposite for angle F, it's adjacent for angle G. Okay, the other thing that you know about these two angles is that they need to add up to 90 degrees, your two acute angles, because those need to add up to 90 degrees when you have a right angle so that the triangle adds up to 180 degrees total. So if you have a question like this that says write sine of 9 in terms of cosine, okay, so really what it's asking you is what is the other acute angle of the triangle? Okay, so if this was sine of 9, you're trying to find the cosine of whatever this angle is here. Okay, because they're going to be equal. You just have to figure out what the other acute angle is. In order to do that, every time you will just subtract from 90, because your two acute angles for a right triangle need to be complementary, meaning they need to add up to 90 degrees. So the sine of 9 would equal the cosine of the other acute angle. You would do 90 minus 9, which is 81. Okay, you're going to do the same thing if it says to write something in terms of sine, if it's given to you as cosine. So this one is cosine of 25. That's going to equal the sine of the other acute angle in the right triangle. To figure out the other acute angle, you just subtract that from 90. So 90 minus 25 would be 65. So the cosine of 25 equals the sine of 65.